In this video, we will discuss Euler's graph. Before going to Euler graph, we will define Euler line. If some closed walk in a graph contains all the edges in the graph, then that walk is called as Euler line. And the graph which contains Euler's line is called as Euler's graph. What is Euler line? A Euler line, a closed walk in the graph which contains all the edges of the graph, and the graph which contains Euler line is called as Euler graph. We shall prove one theorem on this. Statement of the theorem is: a given connected graph G is an Euler graph if and only if all the vertices of G are of even degree. All the vertices of G are of even degree. That means we have to prove that a connected graph G is an Euler graph if all the vertices of G are of even degree, and if all the vertices of G are of even degree, then the graph G is Euler graph. In both ways we have to prove this theorem. Proof. We shall prove this theorem. Suppose G is a connected graph. G is a connected graph. Further, suppose that G is Euler graph. As G is a Euler graph, by the definition of Euler graph, G must contain a Euler line. Therefore, G contains an Euler line which is a closed walk. G contains closed walk. In tracing this graph, we can observe that every time the walk meets the vertex V, it goes through two new edges. It goes through two new edges incident on V. With one we enter the vertex V, and with other we exit the vertex V. Thus, every time we added two edges with one vertex V. This is not true only for intermediate vertices. But for end vertices also. Thus, if G is an Euler graph, then the degree of every vertex in G V in G is even. That is, it is a multiple of 2. Now in second part, conversely, suppose that all the vertices of G are of even degree. Now, we shall start from any arbitrary vertex. V and construct a walk. We shall construct a walk by starting from any one vertex V. For constructing walk, we start from V and going through the edges of G, such that no edge is trace more than once. We continue such a way. We continue such a tracing as far as possible. Since every vertex is of even degree, we can exit from every vertex we enter. Such tracing cannot stop. At any vertex except V. And C, and since V is also of even degree, we shall eventually reach V. When the tracing come to an end. If this is a closed walk, H, we just trace all the edges of G. And hence G is an Euler graph. If not, if we are not cover all the edges. If not, we remove from G all the edges in H. And obtain a new subgraph H dash of G, which is formed by removing remaining edges, which is formed by remaining edges. Now, since all the vertices in G as well as in H are of even degree, we can conclude that the vertices in H dash are also of even degree. Moreover, H dash must touch H at least at one vertex A since G is connected. Now starting from A, new walk in a graph H dash. Starting from A, construct a new walk in a graph H dash. Since all the vertices of H dash are of even degree, this walk must terminate at A. This walk in H dash can be combined with H to form new walk, which starts at vertex A and ends at vertex A. We shall repeat this process until we obtain a closed walk that travels all the edges of G. Of graph G. Thus, G contains an Euler line, and hence by the definition of Euler graph, G is Euler graph. This proves the theorem. Thank you.